Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna try to recreate the LED grid thing that I did the other day using animation nodes, but we're gonna be using sphere choke add-on. So sphere choke nodes, and in general, it should be a lot easier depending on how familiar you are with sphere choke and animation nodes. So SV LED. I've done this in the past, but it's slightly faster now with Blender 2.8, 2.80. So this is official. So I will start with a plane. You can actually use line if you want to make just a straight LED. You can also make like use grease pencil to make LED that's kind of more curvy. But let's try plane and make like 10 by 10, so 100 LED. And we're gonna be using just box. So bmesh is gonna be the output. So we're gonna have 100 box really quickly. So there you go. That's 100 box. And are they all separated? Yep. So they're kind of touching each other. And we're gonna need to give it a bit of material. So this is gonna be LED material. Gonna assign it here, and the material should have vertex color assigned. So I will assign a vertex color. So we have this node that's already been updated a couple of times. So object, and then we have this default color. Let's try random color. So now for every single box, we should have vertex color from sphere choke. And each one of the box can have random color if I assign a random color. So first of all, in the material, I'll assign the SV call, plug this into the base color, or if we are using emission, just plug this into the color, just like that. And we should be able to see a color. So it's this orangish color. Thanks to this single node, it's very powerful. So you can see with sphere choke, you don't need a loop because all the nodes doing this vectorizations. And so let's create a color. We can use create random color. For example, we're gonna need to use alpha with Blender 2.8 because vertex color can have alpha with 2.80 if I'm not wrong. And let's see, we actually need a color in, use alpha. Okay, so color goes in, and now we can control the RGB or HSV. I like to use HSV, hue, saturation, and value, because we can control this. Okay, so just a couple of simple nodes, and we already end up with this LED. And let's actually use the random number generator. So box plane, we are using the vertices of this plane to place the box. So let's calculate how many vertices we have, how many boxes we have. We have, of course, 100. Plug this into the size. We want float. We want random value between 0 and 1. Seed is automatically randomized. This goes into the hue. Okay, so we get a bit of problem there. Apparently, I need to separate this number. Interesting. So yeah, we do have 100 different numbers. We need to use list split, I believe. Okay. Here we go. That's interesting. So it's unwrapping this value. So now we have 100 color goes into this guy. Okay, cool. It's working. I thought I hit an error just now, but there you go. That's some kind of random grid. So with this guy ready, we can perhaps play around with the string. We can use Eevee or Cycles. Cycles will actually, if we have a plane, and then if we kind of make the background totally black, you can see it's kind of glowing. With Eevee, it's kind of glowing differently if we turn on the bloom. So we have that kind of nice bloom color, whichever you like. But we can use Eevee because Eevee is real time. So we can play around with the value over here. But really what we need to push is actually the strength here. If you want to get like a glow, this will also have effects. So there's a plus, and we can randomize the seed here. So yeah, so let's play around with this. So instead of random number, you probably can use a different algorithm or different random value. We can use vector noise or turbulence. That's the easiest one. I always do that. But even with this random number, you can use uniform or others. It's actually quite interesting. I don't play around with this much, but the random, there are all kind of different random numbers, and you're gonna get a different pattern. So that's what really matters for us. Just like if you are using Cycles or Eevee, and then you in these nodes you have all kind of procedural texture like bricks, checker. All this can be used for LED, but we are kind of working in the higher level with Sverchok. So this is probably more interesting. So let's say we are using this plane and then plug this value into the vector noise, and the output needs to be scalar and goes into our color. Maybe, yeah, I think this should work. This goes into the color. Okay, we need to split it once again. Okay, so that's the color from noise, and the value might be kind of too random. We need to perhaps multiply this with a number. Slightly tricky, but you will start to see a pattern. Just now you can see a pattern, right? This is with just 100 cube. If I'm actually generating more, like 40 by 40, 1600, 1600 cube, we can start to see a pattern. So this is actually thanks to the vector noise over here. So this is actually pretty fast. Blender doesn't like too many objects. So 1600 objects is already kind of slow. It's better off that if you join them together. But if we are doing it this way, it's really easier to understand, because we are dealing with objects and then just vertex color. We don't care about anything else. Yeah, we can actually work like this using like a matcap, and and we don't have cavity, we don't have shadow cavity or things like that. But yeah, this is, imagine you have 1600 LED, and this is the result. You can change the pattern from Perlin to Voronoi Crackle. It's kind of nice. Oh, Voronoi Crackle, look at that. Or even Cell Noise. And then, because this is real time, if you go switch to render, you get a glow. That's kind of nice. You can also use the vector turbulence. And this, let's see how the result's gonna be. So I'm using this vector noise and vector turbulence. This is kind of complex. If you are new for this, it's easier if you are using like using the sine wave and then kind of keep adding the complexity from that. So if I'm using just like a simpler LED, you know, like just a single line, that's probably gonna be easier to understand. And then just simply play around with the RGB. Maybe I should do that, or I should revisit this setup and then just using line instead of grid. But I found this really interesting. Yeah. And file save as, because you don't need to just you're not limited to just using plain, but you can also use kind of a cube arrangement, like a vector P, for example, and then you can kind of have like a voxel. In a way, I'm emulating what Cycles can actually do, or Eevee, in the shadow level, but we are doing it at a higher level, and the objects and the vertex color. And if you are doing this LED animation, this is going to be simpler to do. I think 1600 is probably too much, so let's reduce it to 400. So it's going to be more interactive. I'm actually more interested with a interactive result. So a little bit like this. So I will turn on the timeline. I want to animate this. So we have vector noise, turbulence. The value that it's affecting is the hue. You can also actually just play around with the value over here. Let's say you want to have just red color. I know it's going to be red, and you have this value. The value, supposedly, to make this even better, you kind of map the value, arrange the value so it's between 0 and 1, and then you don't clamp it. You kind of want to get the minimum and maximum of the noise from this guy. And then let's animate this vector in. Animate in X. You can see it's kind of sliding or swimming, like a swimming texture, and then Y directions, and also the Z. The Z is going to be the most interesting. So yeah, that's what you get if you're plugging it into the V. You can plug this back into the hue, and back with the hue saturation value that's kind of strong. Reduce the value here. So yeah, that's a bit better. So now if I move this value, you can see this swimming. Seems like it's too much yellow, but you can always control this value and get just a nice spot. Maybe reduce the saturation so we have like a pastel. Sometimes HSV is nice, but HSV RGB is actually can be kind of interesting as well. So if you actually plug in the value of this vector turbulence instead of the scalar, you really plug in the vector into the RGB, you're gonna get different result. So this is the input for our vector turbulence, and then vector out. We're gonna have X, Y, Z, and this can go into the RGB. If you are familiar with Eevee and shader, you can actually emulate this kind of thing, but at the shader level. And at the shader level, sometimes it's easier to understand, sometimes it's actually harder. So let's split this, update. There you go. So what's probably surprising here, if you are new to SpreadChalk, is the list split. It's how you have this like list of value, and then you're splitting the value so that these nodes understand it and generating one value for each box. In this case, one vertex color group for each box. So it's really simpler that way, because the box is being instanced over here. All right, so this box can be anything, can be icosphere or anything, can be Suzanne. Okay, I think 400 is a nice number. So we have 400 cube over here, and we are really controlling everything pretty much. You can make it swimming, move it ups and down. If you want this to be a bit nicer with 400 box, you can select a single box over here, assign it some kind of bevel, and then Control L, make links so each one of the box get a bevel. And then if you go back to this guy, you can have a shadow or cavity. Sometimes maybe you want this, and then you assign a matte cap. It's kind of nice. It's not realistic looking, but it's a nice tile. And you can make it swimming. You can play around with all kind of different turbulence. It's a good setup to understand about the noise value that it's generating, and also color that you get, and then how it's how the turbulence looks like as a color, RGB color. So it looks really nice like this. Yeah, so there you go. We start with something that's random, and then we have vector noise, we have vector turbulence. We learn to list split the value, and then we learn to map range. So there's a lot of things. This can be like a chapter if I ever make a book about nodes and how to cook all kind of values. Well, say we are only like using the nodes like vector noise, turbulence, but there are so many kind of algorithm out there. Any for like math formula, like I said, you can use your own sine wave or math formula just to see how the formula will affect the color, how you can visualize numbers. So that's always interesting for me. I'm not like the most technical person, but I like this kind of thing. It's kind of beautiful. And if you try replacing the plane with different objects like a vector P in this blender, I don't know how to split this guy over here too. So we have different the network or reroute. So this is a reroute here. So supposedly, if we plug this guy over here and then over there, 1, 2, 3, we can just replace this with this guy. So we have a different, totally different arrangement. Oops. Let's make it like 5 by 5 by 5, 125 different objects. Really, I'm supposed to be able to. Yeah, I just updated by switching to different frame. So now suddenly we have this. I actually I bought an LED, an actual LED light that's pretty much doing this, and it's running processing, and then it's generating all this kind of random colored LED. It's really nice actually. This is something that I have it in my room over here, and then the LED is being controlled procedurally by formula, and it's using processing language, so that's slightly more tricky to understand. But if I can if I'm using this, it's a lot easier. So we just need to worry about all these parameters and then sliding the vector that's generating the vector turbulence and how it affects and translate into color. So yeah, I think I've done this many times, but this is actually it's very clear for me. The whole thing's become easier to understand. So yeah, hopefully this is useful for you. Let me know what you think, and I'll see you next time. Thank you. Bye.